Hello, college algebra student. This video is for chapter 6.3, log function. So we are into evaluating log function by translating in an exponential form to figure out what the exponent is, because the answer of the log function is actually the original exponent before the base was being imposed to it. So the next thing is, if I have a log, I know the answer. So what do I know about the input? So again, we would transform it into a log function form first. If I don't have a base, that means 10, right? So that means 10 to the 4 is equal to x. So that means x is 10,000, right? So do this. 3 to the negative 2 should equal to x, right? So this is the base. It is the answer, but it is the exponent's input, and that would be the exponent's output. So that means x is equal to 1/9, right? So it's very easy to do. So you just do 6 to the answer of it is your input, and that is equal to x. So x is equal to 36. And also 16 to the 1/2. So would equal to x. So what is something to the 1/2? That means root, right? So x equal to square root of 16 is equal to 4. Write this as an exponent. So e to the 3rd. So equal to x. So put in the calculator. I can actually show you how you can do it with decimal. Decimal here. So you can use the keyboard. Well, actually, you don't need to, because you just actually do E. They know that it is a special one. See, E is 2.7, that number, to the 3, right? So it is 20.0855. So x is equal to 0.0855. What about log base? X is equal to 0. So b to the 0 is x. So x must equal to 1, right? Remember, log cannot have 0, but the answer could be 0. And then you can use calculator to evaluate log. In most of the scientific calculator, they have log E and log and ln. So you can do that. So let's, in our case, I'm going to show you with the decimal calculator. Most scientific calculator as log, which is log base 10, and also ln, which is log base E. Okay, so log 2.3. Just do this. Just do log 2.3. So that they would know that it is log 10.3617. So that means that what does it mean is 10 to the 0.3617 will give the answer of 2.3. So it's very strange. 10 to the 1 is 10, but 10 to the point something is this. Okay. What about ln 0.8? So I can just do ln. They know 0.8. Negative 0.2231. Negative 0.2231. What about log negative 3? Okay, so let's try. Is it a log log? Log log 10, negative 3. They will say undefined. You're not supposed to have a negative log because does not exist, right? Undefined. Because you know how the exponential function are like this, right? So the range is all positive. So for the log, the domain would always be positive. Domain x would be positive for log function. So if you input anything negative to it, that would be undefined. So that's the reason. And we'll use this in 6.4 when we study graphing of log function. What about ln 199? ln 199, 5.2933. So you could freely use the decimal calculator to find these for yourself, or you can use your scientific calculator. One thing to remember is if if it is not log and ln, if it is other base like log base 2, say for example a log base 2 instead of 4 or 8, 1.1, what is it? So you would need to use the calculator, but most calculator doesn't have log base 2. So you would use a change of base formula that will be covered in chapter 6.5. And there is also two special log value that you should know. That is two special log value, that is log base b, that would be 1. So for example, if I say log base 5, but the inside is 5, that is 1. Okay, remember this is not exponent. That means the log is log base 5. The inside is 1. Why? Because 5 to the power 1 is 5. 5 to the power 1 is 5. And then log base anything, if you have 1 inside, that is equal to 0. Why? Because b to the 0 is 1. Okay, so that is the end of 6.3. We'll do 6.4, which is a graph of log function.